Now, we're going to talk about the mathematical practice number 1. Make sense of the problem and persevere in solving them. Now, from the last one, we learned that this is an overarching one that ties into all 8 of them, and you do over time. This is not one. So, one quote that I like from the book Putting the Practices into Action by the NCTM is problem solving is not an algorithm to be practiced or a fact to be memorized. Effective problem solvers decide what is being asked, what is important to consider, an appropriate path to the solution, and the reasonableness of their action. So, one question that comes up is, how do I make a problem-solving class? Well, what we need to do is we need to look at the definition of what this means, which this is also on the core underneath the mathematical practice. We need to explain, we need to look for, we need to have a plan, and we need to choose the pathway. What happens a lot of times, especially when we're doing story problems or real world application to the problems, is that we want to get the answer done quickly. Now, I think that this comes from multiple worksheets and multiple problems, or worksheets with 30 problems on them, and we say, okay, get this done as quickly as you can. And we might not say as quickly as you can, but when we say, okay, get this done, whatever you don't get done here, you can do as homework. We create a class culture that has the attitude of we need to get it done quickly. And what we need to have them do more is explain, look for, and create a plan. So as we create a culture in our class, we need to have students be able to answer these questions, and we can do that by modeling it ourselves. And so here are some questions that you can ask, or that you can get the students used to being able to ask, so that as they go into a problem, they understand that this is not something that needs to be done quickly. This is not something that needs to be done now. We need to think about these things before we approach the problem. Am I able to do this? So before they look at the problem, think, okay, first question I need to be able to ask is, can I do this? Am I able to do this? What if I get stuck? What are the strategies they're going to use? Are they going to use resources around them? Are they going to ask their neighbor? Are they going to ask the teacher? What are they going to do if, and I should say when, they get stuck? What if it takes me too long to get the answer? What do we do? What are the next steps? Is it okay if it takes me a long time? Yeah, it's okay. What we need to do is we need to be able to have those steps ready so that we can move forward. And what if my idea doesn't work? Is that okay? What if my idea doesn't get me to the answer? What do I need to do? What steps should I take? Should I reevaluate the problem? Should I talk to my neighbor? Should I compare what my neighbor is doing compared to what I'm doing? Should I talk to the teacher? What are those steps that need to be done if it doesn't work? And what if my answer is wrong? Is that a bad thing? So much goes into finding the wrong answer so that we can eventually find the right answer. There is huge value in showing kids what works and showing kids what does not work. A non-example is a great way to show them what works and why it works, because when we do this, it doesn't work. So as we create this culture in our class, we need to be able to model it ourselves. It's okay if we get up in front of the class and we get a wrong answer. What do we do? What's our next step? How do we find out where we should go next? And what are our resources to help us get the right answer? So how do we get there? One thing we need to think about is, are we asking questions that have many entry points? Meaning, if we ask the question, what's 4 plus 3, there's one entry point and there's one exit point. Are we asking questions that get our students thinking, more than just what is the one correct answer? The other thing we need to do is, and I'll give you more examples of this coming up. But the next thing we need to do is, are we giving students time to think about and explain their process? Instead of giving them a worksheet of 30 problems, why can't we give them 5 and have them explain or draw or interpret what they're doing? Because then we're not creating a culture of you need to get this done quickly. We're creating a culture of we need to understand what we're doing. The next one is, are our questions frequent, purposeful, and high level? Don't just ask them the same question of give me this answer, or what happens if I do, what do I do next? But maybe ask them, what would happen if I did this next? And so give them ideas of things that they can explore. Give them opportunities to dive into the problem. And then, do we praise their efforts with value placed on persistent and process rather than the right answer? And so, is our wording, hey, you're really smart, you got that right, or wow, you worked really hard to get this far. Let's look at and see if it got us the right answer or if we need to adjust. We need to look at the process, their persistence. We need to look at, are they trying things? Are they exploring? I tell my students that I love to see what's going on inside your brain, but I can't see inside your head. So when you write it down, now I can see what's going on. And so have them write it down, have them understand what they're doing, not necessarily because you have to show your work, but because what we want them to do is we want them to understand the process. Now, as they get quicker, as they start to understand it a little bit better, as they become more efficient with the math, maybe they don't need to show their work as much, but do they understand the process? Are we praising them for the process? Are we praising them to persevere on rather than, oh, you got this wrong, do it again? Look at the process and look and say, oh, you got these steps. Why did you do this and this and this? And ask them those questions and praise them for working hard. We need to focus on the question. So here's an example. If we post a data set on Monday, and then that remains up all week. Now, this could be a graph or a chart or just some pieces of information, but then we pose them a different question each day. So if we're in the younger grades, maybe we have how many kids like certain colors. And then we can say, oh, how many more kids like red than blue? Now, one thing that they have to look at is, do they need all of the information? Not with that if they have lots of different colors. Now, the other thing is, when you do this, give them time to talk. Give them time to think through, what would I do? Facilitate a class discussion. Give them opportunities to share their ideas, because one kid might have an idea that other kids haven't thought about. Now, that idea might be a good idea, or it might be an idea that's not going to get us to the right answer, but they're able to share ideas. They're able to feel that it's a safe place, that they can share what they're thinking, and it's okay to make a mistake. And then the last thing is from this type of thing is that you don't necessarily have to have a written answer. Now, it's sometimes easier to collect and grade or whatever, but the most important part is that they're having a conversation about the question you asked, that they have to figure out what pieces of information do they need, because a lot of times we give them a problem and then we just use all of the information that's available. But if you give them 5 pieces of information, they only have to use 2, or they only have to use 1, or they have to, add 2 and subtract 1, whatever it is, depending on your grade level, give them opportunities to discuss. And this activity shouldn't take more than 10 minutes. But think about the culture you are making of it's okay to take time to process what we are doing. Here's some examples of a traditional math problem compared to a rich math problem. Now, a rich problem are those that require students to think beyond a quick response. So, what is 6 plus 4? There's one answer. There's one entry point. There's one quick answer that they can give you. But what about this? 10 children went to the movie. There are boys and some girls. How many boys and girls are there? There's lots of different answers they could have, but we're trying to figure out if they know what makes 10. What a great activity for first grade when we're trying to do partners of 10. And then think about, is there a different answer? So some kid has 5 and 5 because they know they're doubles. Well, is there a different answer? Let's have a class discussion about what it could be. And they're able to explain their reasoning. They're able to persevere through. Here's another interesting one. This is a second grade question I see lots of times. Molly has a quarter, 2 nickels, and a dime. How much money does she have? Now, they do have to think about that. They do have to think, a quarter is 25, and nickel is 5, and we've got 2 of those. And so they have to put those together. And that's a great idea. But Molly has 6 coins in her pocket. She has more than 85 cents, but less than $1.10. What coins could she have? Think about all of the entry points. Let's say a kid says 6 pennies. Okay, so they have 6 pennies. Does that fit our criteria? Is that in between 85 cents and $1.10? All of these different things, comparing numbers, all of these different parts of the core that they're able to explore. And then I love this one. I love this one when I taught 7th grade. A rectangle has a length of 4 units and a width of 3 units. What's the area? Easy for them to do. There's one answer. But what about this? Create a rectangle with the area of 24 square units. Now create a different one. Are they alike? Are they different? Are the perimeters the same? Because what happens is we get so caught up in multiply to find the perimeter, or multiply to find the area, add to find the perimeter, the kids get confused. So give them these problems where there's not one right answer. Now, how do we grade this? We're not trying to grade this. We're trying to get them to think through the process. Think through what is area, what is perimeter. Think through what is the value of these coins. And so that now, as they're able to think through, they're able to get a deeper understanding of all of these concepts. So, some things you need to think about. Do I routinely provide opportunities for my students to share their solutions and processes with partners, with groups, and or the whole class? Are they having opportunities to talk about what they are supposed to be doing? Talk about their thinking. Talk about why they did what they did. Do I show my students that I value the process rather than the correct answer? This takes some time. Now, sometimes if you are working through problems and you're trying to show them how to do it, you want to get through 10 problems. When you're doing this, maybe you only get through 3 or 4. But I will guarantee that the students will have a better understanding of what they are doing rather than just regurgitating information. And then the last one is, do I pose problems that require perseverance? Those 3 examples that I had require perseverance. There's lots of different answers. As soon as they get an answer, you can always say, is there another way to do it? If you want to differentiate in your classroom, pose those rich problems, because now you have those kids who are always done first, and you say, is there another way that you could do this? And now they're going off on another problem, and those kids who take a longer time to process have one problem that they need to do and think about it. What a great idea to differentiate. And you're only asking one question. The best explanation of differentiation is asking the same kids the same problem to the same kids. Let me rephrase that. Having kids think about the same problem in a different way. Give kids problems that they can think about, that there's lots of different answers. There's lots of different ways to explore it. There's lots of different paths to get to the right answer. And that's differentiation. And do I use thoughtful questions to guide and encourage students as they struggle with problems? This does not happen on the fly. You need to create these questions in your planning process. The textbooks have these questions, but there's like one of them at the end. Every textbook has these questions, or most textbooks do, but there's one question at the end and not 4 questions in the problem set. So do the problems where they have to think. Now, the problem that we have is that in math, we have to get one answer. That's the way math has been set up. That is not the right way to do it. Get them to think about the process, think about other ways to explore things, and then they will understand how to do the math. As you finish this, there will be some questions following this that you need to answer in order to get credit for this.